Hello everyone. Have you ever stood in front of those giant curved mirrors in amusement parks? One second you look like a tall giraffe, the next second you look like a squashed pumpkin. Funny, right? But here's the twist. No matter how funny you look, the laws of reflection never cheat. Yes, the same rules that hold for a flat mirror also hold for a spherical one. The angle of incidence equals the angle of reflection. In symbols, I equals R. And remember, the incident ray, reflected ray, and the normal all stay in one single plane. So whether it's a bathroom mirror or a giant curved mirror in a funhouse, physics keeps the rules rock solid. Now comes the tricky part. How do you find the normal on a curved surface? Unlike a flat mirror where the normal is obvious, here the trick is to connect the point of incidence on the mirror with the center of curvature, marked C. This line is always perpendicular to the mirror at that point. That's why C is like the master reference, every normal points straight towards it. As you can see in the diagram, we first draw the normal DC before applying our golden rule, I equals R. Let's practice this with a concave mirror. Suppose a ray AD falls on the mirror at point D. To apply the law, we first join D with the center of curvature C that gives us the normal. Now the law says the angle of incidence equals the angle of reflection. So, angle ADC equals angle BDC, which means the reflected ray is dB. So in a concave mirror, rays bend inward as if they're gathering for a meeting at the focus. It's like all the rays are introverts, they love converging. Now let's flip to a convex mirror. Same ray AD striking at D. Again, we draw DC towards the center of curvature. Now the reflected ray dB is drawn so that angle ADC equals angle BDC prime. But here's the difference, the rays don't actually meet, they diverge. We have to extend them backward to see where they appear to come from. So in convex mirrors, the rays behave like extroverts, always running away from each other, never really meeting in real life. So, what's the general rule? Simple. At any point, first draw the normal towards the center of curvature. Then make sure the incident angle and reflected angle are equal with respect to this normal. That's it. No matter concave or convex, this is your universal recipe for drawing reflected rays. Equal angles on either side of the normal, physics loves symmetry. Let's test this with an example. Suppose a ray AD hits a concave mirror at point D with C as the center of curvature. How do we find the reflected ray? Step 1. Draw the normal DC by joining D to C. Step 2. Apply law of reflection. Angle ADC equals angle BDC. Step 3. Draw reflected ray dB on the other side of the normal. And there you go. Reflected ray dB is found and the law I equals R is satisfied. The trick is simple, always use the center of curvature for the normal. Alright, let's tie it all together. Reflection in spherical mirrors may look complex at first, but it's just the same old law of reflection applied with a clever normal. The center of curvature decides the normal, and the angles of incidence and reflection stay equal. Concave mirrors bend rays inward and can form real or virtual images. Convex mirrors spread rays outward and always form virtual, diminished images. So whether it's the rearview mirror of a car or the big telescope at an observatory, the same simple law, I equals R, keeps working behind the scenes. That's the beauty of physics, simple rules, extraordinary applications. I hope you enjoyed reflecting on this topic with me. Until next time, keep your angels equal, your curiosity alive, and I'll see you in the next session with more mirror magic.